Hello, everyone. Welcome, and thanks for joining us on this session on building a scalable cloud-native platform, the key to success. It's great to be here. This is my first time presenting and attending the GIDS conference. It's amazing to see so many like-minded people sharing the same space and collaborating. So before I get started, the organizers were correct. A lot of people are staying at the back. I'm not going to bite. You can come forward. It's okay. I know it's a lecture hall, so everyone wants to sit in the back and goof around. It's okay. You can come in the front. So just a quick show of hands. I have two quick questions, okay? How many of you are currently using Kubernetes? Oh, fantastic. And how many of you thought that using Kubernetes is going to solve all your problems, but actually is creating more problems? Don't be shy. You can lift your hands. All right. So today I'm going to focus on how you can build a scalable cloud-native platform, draw from my experience of being in this space for so many years, talking with companies, how they are currently developing their platform, the struggles they have seen, and take from those learnings and share with you all. So let's get started. Just a bit about myself. I'm Neeraj Poddar. I'm head of engineering from Solo. I've been a long time maintainer and leader in the several open source communities in the cloud native space. If you're familiar with Istio, I'm on the Istio technical oversight committee. I'm in a long time leader there. I'm a former steering committee member. I'm always happy to chat with you all. So please reach out to me on Twitter or NRJ Poddar or LinkedIn. So with that, we'll get started. So this is the rough agenda. I'm going to just take a few minutes to talk about Solo, who we are, what we do. Then we're going to look back and understand how did we get here, where we are in this cloud native journey. I'm going to introduce a new concept called Cloud Native 2.0, what that means, how it will affect your organizations and you, and then how can you help build a scalable platform. So you have to choose the right foundations. I'm going to also introduce Glue platform, which takes all these concepts and is a product from Solo that will help you in this journey, and then we'll open the room for questions, okay? So first about Solo, who we are. It's good to follow a CMO in your slides, in your presentation. I don't feel bad about talking about some of the marketing fluff I have on my slides now. So Solo is a very well-funded startup based out of Boston. We had Series C funding 2 years ago around for $135 million. And we are constantly growing, not just in revenue, but also in terms of hiring and onboarding new people and customers. We have a long list of customers. I'm going to use the next slide to talk about the customers we have in various sectors. But the key thing is we are the cloud native technology experts. We are offering a platform which is geared around application networking. And our aim is to connect, secure, and help observe any application anywhere in your environment. The key to all of these products that we have is that we are built on strong foundational open source technologies and communities. We are not only using these communities and products, but we are also leaders in them. We help make sure they have a good ecosystem. Like me, we have several other leaders in several open source communities. Who among you have seen these logos, right, underneath? Obviously, people know Kubernetes. How many of you know Istio? All right, I see a few hands, good. GraphQL, Cilium, eBPF, any of these? All right, awesome. All right, so but since I wrapped them all in one question, I don't know how many of you know each other. So we'll come to my booth and we'll talk about if any of these projects or concepts are interesting to you and how we can help, okay? And just very briefly, we have customers relying on our products and using us in all the different verticals that you can think of, right? Whether it's telco, financial services, retail, the software enterprise industry, gaming industry, media, government. And the way we work with our customers is we build a strong partnership. And not only are we helping them in the cloud native journey, whether it's going from on-prem to cloud or from one cloud to another, or expanding and scaling the architecture, we also make sure that they are successful when they are thinking about their future, right? That's our main aim, making sure our customers are successful. So with that, I'm going to now paint you a journey of how did we get here. So what led to the changes and what all happened in the industry where we all are in this room talking about cloud native technologies, right? And not just the cloud native technologies where we are today, but what changes happened and what are happening right now that will take us to the next stage, right? So one thing that has been happening in the industry for the last, I would say, 15 years, and the main buzzword that you must be hearing everywhere, whether it's any marketing slide or any consultants, if you are a part of a large corporation, is digital transformation, right? I'm assuming all of you are familiar with this word, right? Heard it many times. So digital transformation is basically using digital technologies to help transform any product, any workflow, any process you have in your organization to make sure you're meeting your emerging business needs, right? To make sure you are meeting your user demands. And even though there's a lot of marketing fluff around it, the concept is powerful. So when you look at the last 15 years, there's been emergence of new technology. Mobile phones are pervasive everywhere. The consumption patterns of users have changed. So we have companies like Uber, Ola in India, Airbnb, who were born in the cloud, who were built to scale and meet these user demands. They had themselves not anticipated, right? So they are pushing the envelope in terms of how can they scale to meet the ever-increasing users, whereas there are traditional companies who are trying to make sure they transform the internal processes and application workflows so that they stay relevant. They can compete with the incumbents who are trying to disrupt them, right? So this is the two main drivers that you see that are pushing people towards this new cloud-native landscape, right? And a key part of this is many companies are moving to the cloud, and that shift is because, again, they want to be more agile, they want to be operationally more efficient, they want to expand when needed. So many of you must be going through this motion, right? You have lots of on-prem clusters or on-prem infrastructure that applications are running on. Most of the time they were working, but now you all are moving to the cloud, right? And digital transformation and the ability to compete for these companies with the incumbents is what drives this motion. And then many of you, like you raised your hands, have already started with Kubernetes, right? So containers are a standardized infrastructure technology now. We use containers to share our applications with each other in a well-contained format, and then running them with Kubernetes to make sure it is orchestrated in a very efficient way. You get the basic benefits out of the Kubernetes orchestration layer. It's all table stakes now, right? And then we are trying to build these applications which are more cloud native, right? So that's interesting. So many of you are working with monolithic applications. They might not be truly native to cloud ecosystem. So when you talk about cloud native apps or cloud native in general, it doesn't mean that we are just now running in the cloud, so now you're cloud native. What it means is, do you have the right processes, workflows? Do you have the right application in the architecture that you can mirror from cloud providers like AWS, Google, take the best practices and patterns so that your application, your team, and your company can scale like the cloud, right? That's what cloud native is. So in that paradigm, shifting and lifting a monolithic application from your on-prem cluster to the cloud doesn't really work. You have to think about it in a cloud native way because those monolithic applications won't have the right primitives to help you scale, to get observability, to get security in a cloud native way, right? So if you're still deploying and making configuration changes through your GUI and you are on your Kubernetes environment deploying microservices, you're still going to see some struggles there, right? And then what we have seen is there's a lot of early success here. Lots of innovations have happened. Lots of folks have moved from on-prem to cloud. Lots of people are using containers, Kubernetes. Lots of people are bought into this declarative configuration paradigm. All of that is really amazing to see, right? So we have a lot of success, but then we have to think about what's next. How do we scale beyond just one cluster? How do we scale beyond one cloud? How do we scale beyond one region? So that's where we are, right? So how do we take the next steps? Every success for everything we do, it's amazing that we are successful, but it also gives more complications, right? And that's what we're going to talk about now. But very quickly, again, how all of this started, right? And I think all of you have gone through this journey, right? So how many of you have tried to decompose your monolith to microservices or are actively doing it? Show of hands. All right, a large number of people. I mean, this is the developer summit, right? So you guys are the ones driving this. So very quickly, so monoliths worked fairly well for the large part of the software industry, right? The idea was we have one application written in one language which can do a lot of different things. It will still have composable pieces, but those composable pieces are libraries and functions that can call each other. Very efficient. When you scale them, you have to scale them in one unit, right? So if you have 3 VMs running one of my monolith application, I can put a load balancer or API gateway in front. I can expose it, but then to scale it, I have to scale everything. So it's not very efficient in terms of scaling. In terms of security, since all of this is part of one big binary, thinking about a threat model, thinking about a security exposure is very difficult. Baking reliability into this is also hard because the only thing you can do is replicate everything, right? So the shift from monolith to microservices was, can we break this application into small services that can communicate efficiently with each other? And these services can scale out independently, depending on the user demand. So now you get better resource utilization, better scalability. These microservices are small, scoped, purpose-built, so you can have developers and their teams choose the right tools to build them, right? So you can have somebody building them in Java, somebody building them in Python, and they can all talk to each other with well-defined APIs. And most of the time, these are gRPC or HTTP APIs, right? And then you still need an API gateway to get it externalized and in front, but now there's a lot of communication happening between them, right? So this was a massive philosophical shift for everyone, right? So for me, it was because, we were all running monolith applications, we're fairly happy, but there's a lot of benefits to this architecture. That's why we're all doing it, right? This gives us the ability to iterate much quickly. You don't have to go through a 20-day release process to build a microservice. You can build it instantly, make sure if you have the right pipelines, deploy them, and you get faster iteration cycle, right? And then we standardized a lot of this infrastructure so you can run anywhere as long as you are built and delivering your application using Docker, and then if you're using Kubernetes, you can run on any cloud, right? So there's a lot of benefits that came from this shift. One thing that I've noticed is, every talk that you have nowadays, it's incomplete without throwing in some AI magic, right? So what I did, I went to ChatGPT and asked to create a haiku on cloud native, right? A haiku is a 3-line poem in Japanese. It has 5 syllables, right? So this is cloud native beauty, infinite possibilities, born in the digital age. So if you see, it says 6 out of 6 because I tried 6 times. The first 5 times were really horrible. So the 6th one was pretty accurate. And indeed, cloud native gives you infinite possibilities. So when you look at it, this is what the cloud native is. It's actually infinite possibilities, right? So how many have seen the CNC of landscape, right? It's really hard to freaking understand what's going on here, right? So what happened? So people are moving to from monolith to microservices. They are using Kubernetes, but still there are a lot of gaps in that ecosystem. You still need security to make sure whatever traffic comes from outside in is secured. You need to have the right validation, authorization, access policy, and controls in place. You need to encrypt your traffic even within the Kubernetes environment because now you're using microservices. So every hop between those microservices should be encrypted and authorized again, right? For managing databases, you need to pick the right tools. If you're managing persistent store, you need another set of tools, right? If you want observability, like there's a whole suite of observability. I mean, I was at KubeCon in Europe, last week. Any of you went to KubeCon by any chance? All right, so awesome. So you will see so many vendors talking about the same thing. So this space is very confusing, right? Many independent solutions came up, and they were all trying to fill the gaps because moving to Kubernetes using microservices is the starting point. It's not the end point, right? For many of us, even that is a big lift, but we need to go further from there, and these projects were just filling those gaps. But this is just a wild west of open source projects, right? A lot of them there. It's very hard to understand which one to pick. It's very confusing if you're an organization or developer trying to use them, right? And this is where we are today, right? Everyone using Kubernetes, or most of you using Kubernetes and containers, but then struggling to understand how many of these projects should you use and compose to make sure all of them work together, right? So I want to talk to you about then what the next evolution of this cloud native ecosystem looks like, which I would like to say cloud native 2.0. So we talked about cloud native 1.0. So we are using clouds, Kubernetes containers. We have lots of new innovations. We are using standardized infrastructure, microservices. So what are the challenges? So how do you get API scalability, right? So many of you raised your hands when I asked about GraphQL. That's an interesting pattern to make sure you can have faster load times and better user experience. Do you have API gateways that natively support it? Do you have API gateways that are distributed? Do you have API gateways that are configurable through a declarative GitOps workflow? If you have all your applications being deployed through the GitOps workflow, but your API gateway is still through a web GUI that you're using, you're still vulnerable. You're still not totally cloud native, right? How do you get microservices scalability? How do you get zero trust? Somebody just in my booth was asking, what is zero trust? Zero trust is literally don't trust anything. It says zero trust. You verify all the traffic that comes to you, and you have to verify it through in a cryptographic way. So it can't be repudiated. Right? You want to go from one cluster to another, how do you do multi-cluster management? You can't have these snowflake clusters, and you want reliability across regions, but you're managing them piecemeal every time, right? How do you get observability? And then lastly, how do you standardize on GitOps, right? So this is what we want to solve now in Cloud Native 2.0. Yeah, so when you look at it, all the problems that we talk about in 2.0, you can kind of categorize them in a few areas, right? And this is how I like to categorize them. So you need to modernize your API management, right? So API gateways and portals have existed for the last, more or less 3 decades. It needs to be refreshed. It needs to be modernized so it feels cloud native. You need to have the right DevOps, SecOps, or all the permutations that you can do with developers, security, networks, and add ops in front. But the key is you need to be able to deploy your applications in a GitOps-friendly way, right? You don't want to use GUIs for manipulating configuration at production. You want to store this configuration in Git and make sure you have you can have change log management just like you do for code. You need service mesh to provide zero trust to observability, right? So service mesh is the infrastructure layer that can handle communication between these microservices, right? And as it does that as part of your infrastructure, it does security for you, it does reliability, and it will give you a lot of observability, right? So I've spoken to many customers who either need compliance because they're trying to do FedRAMP, FIPS, or they have some other regulatory requirements in their region. And service mesh is one of those fantastic ways to achieve that. And then you want to scale your microservices to multiple clusters, multiple regions, multiple clouds. And then as we talk about scaling APIs, another aspect of it is how can you natively consume GraphQL and serverless, all in the ecosystem of running your applications, most of them on Kubernetes, right? They should not be disjointed pieces of infrastructure. For GraphQL, you run this thing in a VM. For serverless, you run another thing. So we need to bring this all together, and that's what Cloud Native 2.0 is. All right. So I've been an engineer all my life, and for me, the best part of being an engineer is thinking about the right architecture, right? So when you evaluate and you're doing design for something new, building the right architecture means making sure you have the right foundations. So now when we're talking about the cloud native architecture and the cloud native platform, it's key that you build it on the right foundational open source projects, right? So this slide kind of summarizes some of the choices we have had to make in the last few years, and some of us are still making these choices. So how many of you have used Mesos? All right. Are you still using Mesos, sir? Thank God, right? How many of you are using Cloud Foundry, Pivotal Cloud Foundry? All right. See, so there are remnants of these technologies that did not win these wars that we still are stuck with and have to migrate, right? Not all of us are fortunate enough that we can just start with Kubernetes. Right? Similarly, when you are trying to choose a foundational proxy for doing API gateway, for service mesh, for load balancer, there were many choices, right? I just added 3. There was Big IP, there's a Citrix, there's a whole range of technologies that used to sell their products as appliances, right? And we have all run them. But now when we talk about cloud native, we have these 3 options that are emerging. We have to pick the right ones, right? Similarly, for service mesh, we have seen a lot of proliferation of different vendors and different projects, but not all of them have the same vendor neutrality and the community support that you want. Not all of them have the same functionality, performance gains, and the right architectural design. And then we talk about CNI layer. This is the fundamental layer to give you networking for your Kubernetes environment. Again, there are a lot of choices. You have to pick the right one so that you're set up for success. So for me, that's the key part of building a scalable cloud-native platform, right? Can you choose the right open source technologies that set you up for success? So, and that's what Glue Platform is. So Glue Platform is the product from Solo, which basically takes these key open source projects, puts them together in a platform form factor. We provide a higher level API abstraction. This API is built to be consumed by applications instead of lower level networking primitives that we provide. This API is abstracted, so you can think about it in an application form using flexible label selectors, irrespective of where your application is deployed, irrespective of how it is deployed. Is it Lambda? Is it a virtual machine? Is it a Kubernetes cluster? Or as a Kubernetes container, right? Your developer should not care about it. They should care about just the policy I want to apply to an application, irrespective of its physical form factor and location. And we do that by taking these technologies and providing this abstraction for you, right? So just going a little deeper into what Glue Platform is, so there are three key parts of our offering. So Glue Gateway is the modern API gateway built on Istio and Envoy. We have lots of maintainers and expertise on both these projects. So we take Envoy, we are extending it to add a lot of key enterprise-grade functionality like web application firewall, data loss prevention, external authorization, and rate limiting. And then the key is we still use Istio for configuring this Envoy as an API gateway, right? And then we provide a layer above Istio. So our APIs are sitting on top of Istio. And we provide a management plane that will take the APIs and users provided configuration and lower it to Istio configuration. And we can do this for multiple clusters. We have customers using it for hundreds of clusters. And that's the scalability we provide. Glue Mesh is the enterprise-grade service mesh built on Istio. The key here is the same data plane that we are using for Glue Gateway at the north-south is available for you in the east-west. So one of the emerging trends that we have seen is there's a convergence of functionality between north-south API gateway and service mesh. Folks have different requirements in the organizations depending on how your business units are structured. You might have rate limiting requirements and consumption and developer portal requirements even within your organization, not just for external facing customers, right? So providing the same capabilities is very, very important. And then Glue Network is the supported CNI that we provide. This CNI is built on Cilium. How many of you have heard of Cilium before? All right, very cool. So Cilium is the eBPF-based CNI. eBPF is Extended Berkeley Packet Format Filter. It allows you to dynamically program the kernel by adding events, by adding programs to various events, and then take those signals from those programs and expose it to user space if you want. It's very powerful, and we are very vested in that technology because we see convergence in not just north-south and east-west functionality. We also see convergence in service mesh and eBPF, right? And that's our job. If you pick the right technologies and right projects for each layer, you can combine them to make it an even more powerful platform. So for me, the key to success, how much time do you have? 5. All right. So the key to success for me is if you're building a scalable cloud-native platform, is to focus on these areas, right? So you need to understand your goals and requirements, especially around reliability, scalability, and security, right? So for scalability, you need to understand, are you going to be using multiple clusters? You will have one giant clusters. Are you going to be using multiple clouds? For reliability, do you have cross-regional requirements? I spoke with few customers in Europe, and based on the regulations there, they need to be on multiple clouds. This is where the industry is moving, right? And then for security, can you have similar technologies to make sure you can do access control and encryption everywhere, right? The next thing is pick the right foundational technology, right? So you have to make sure you're picking the right open source projects which are well maintained. They have a thriving community, right? So we all have seen the effects of using something that didn't pan out, whether it was Mesos or Pivotal Cloud Foundry, even though they were amazing technologies, right? And then the main thing for me is how can you commonize and abstract, right? So a lot of similarities for the various technologies and benefits that they offer. You should be able to standardize your technologies. You don't need to have multiple proxies doing similar things. You don't need to have multiple pieces of software providing certificate management. And then can you create an abstraction for higher level so that you can hide the complexity, right? So as a platform that you are building, you don't want your developers to understand the nitty-gritties of service mesh, for example, or the nitty-gritties of CNI. And the last thing is we all have to choose in this environment, what are we going to build, what are we going to buy? There's a lot of open source technology out there, but it does not mean that you should be consuming it and running it directly in your production environment, right? For me, it's always just as with life or with any technology you build or any company, you got to choose the right partner, and often that leads you in the right way. You don't have to use the products, but you need to make sure you are getting the right guidance, so you're building a scalable platform. With that, are there any questions? Thank you.